So that will be all for today. Any questions sa pagkuha ng electrostatic force?
Itatanong ko pa ba? Baka isipin ng iba. Ang hina kong mintindi.
If that's the case, see you all sa ating next meeting. Isa-send ko lang ang activity nyo sa Google Classroom, okay? About the electrostatic force. So, see you all.
Introducing LawCal-E, a Python-based system designed to elevate the understanding and application of fundamental electrical engineering laws. Whether you are a student mastering the basics or a professional needing quick calculations, LawCal-E simplifies complex equations into accurate and user-friendly outputs.
The first part of the program contains the introductory message of the system. Here, the user is welcomed with a description that introduces LawCal-E, a tool to help in understanding fundamental electrical engineering laws. There are two initial options. If the user types 1, it will be directed to a new menu where they can select the specific law they want to solve. If the user types 2, a thank you message is displayed. Afterward, the system asks whether they want to reset the program. If they enter 0, the program sends them back to the main menu, allowing them to use the system again without closing it.
Once inside the law selection interface, the user is presented with the following 6 options. Firstly is the Ohm's law, then the Joule's law of heating effect, Coulomb's law of electrostatic, Ampere's circuit law, Gauss's law, and lastly, the return to main menu.
Each of these laws is clearly labeled and the user can solve for different variables depending on which value is unknown. The system asks for input values and calculates the unknown one accordingly. To avoid confusion, the user is instructed to leave the unknown value as 0. For example, in Ohm's law, the user can solve for voltage, current, or resistance. In Joule's law, the user can solve for heat, current, resistance, or time. In Coulomb's law, the program calculates the electrostatic force using fixed values and user inputs for the charges and distance. In Ampere's law, it solves for the magnetic field based on the distance from the wire and current. In Gauss's law, it solves for the electric field using charge and area inputs.
To ensure the program is user-friendly and error-resistant, it makes use of try and except blocks. This helps catch invalid or non-numeric inputs. For example, if the user accidentally enters letters or symbols instead of numbers, the system will not crash. Instead, it shows a message saying, "Invalid input, please enter numeric values only." This feature is applied across all 5 laws.
The visual layout of the system also enhances clarity. Decorative lines made using dash symbol multiplied to 130 to separate each section, making it easier to read. The names of the laws and menus are printed in bold using anti-escape codes to give them emphasis.
After solving a problem, the system goes back to the law selection menu so that the user can solve another problem of their chosen law. Otherwise, if they chose the 6th option, they are then sent back to the main menu.
Finally, if the user wants to exit completely, press 2 for the main menu. The program shows the closing message and gives them one last chance to restart by pressing 0. This makes LawCal-E a helpful, organized, and flexible system for learning and solving electrical engineering equations interactively.
Buti na lang, nandyan si LawCal-E. May karamay na ako sa tuwing magsosolve ako.